Hi, welcome to another service proxy for Kubernetes Cloud Native Network Functions demo. In this demo, I'm going to demonstrate the NAT64 and NAT44. This is just a recap on what we have discussed in our last video, where I have a UE client, default gateway to the ECMP router, and ECMP routers will connect to the SPK or F5 TMM to do these courier grade netting, NAT64 and NAT44, and to get to the web server and to the internet. Here's the UDF blueprint that you can spin it up and look up for this SPK CGN IPv6 dual stack, and you can log on to each of this environment to run the demo. I already pre-log into all this environment. What I did is that I pre-log into the management jump host as well as the backend server, and I had RDP to the Ubuntu desktop, which is act as a client. Before I run the demo, what I'm going to do here is that I'm going to spin up the SPK. What you need to do is you log on to the SPK directory, and I'm going to run 01 onboard SPK. So what it does is that it creates the namespace, it creates all the network attachment, the data network, create all the certificate, this gRPC certificate, the DSSM certificate, as well as deploy the F5 DSSM, the distributed sessions manager or management. Currently, I already run that. So let me quickly run through on what exactly happened in the scripts where it's trying to spin up. If I cat this file, as I mentioned, it created a namespace called my SPK. It's deploying all the interface, the MAC VLAN interface dual stack, ENS6 and 7. It also deploy all these certificates secret and as well as the key. So these are the certificate that is required to communicate with F5 TMM via the gRPC. The DSSM, I deploy the DSSM certificate as well. In this demo, we are not really using the DSSM yet. This is just for demo purposes that I spin up the DSSM. Here we install as a Helm chart to deploy the DSSM as well as the F5 ingress. Alright, so now it's waiting for this to spin up. There's one thing that's important to understand here is that, as I mentioned in previous document or in the previous video, I have an LSN pool that's currently created. So what happened here is that at this stage, I'm not setting up any LSN pool advertisement. So what happens is that in order for this IPv4 web to be able to get back, what we need to do is that just need to set up a static route here to make sure that any IP addresses belong to this range throw back to the F5 TMM. So in order to find out what is the F5 TMM, you can see that the F5 TMM will spin up pretty quick. I have 4 ports here. If I run a describe, you can see that there's a few interfaces that got set up. And all these interfaces there are 2 IP addresses, IPv4 and IPv6. In fact, if I show you let me see. You can see that this is the IPv6 dual stack, and I have the, maybe I'll put -0y. I have the ports running IPv6 and the service running IPv6 and some of the class IPv4 as well. Alright, so now we need to find out what's the IP addresses on the right side, which is 10.1.20.25, which is what's the TMM IP address. So what I need to do is that in the LSN pool here, I just need to set it to 25. So what it means here is that on the backend web server, I say that anything that from this LSN pool throw back to the F5 TMM. This is just an interim solutions where there's no LSN BGP advertisements on the IP address. So I'm going to save this. Alright, so what I mean here is that anything that need to talk back to 10.10.10, it will return back to the F5 TMM. Alright, so you can see that now everything is up and running, including you can see that there's a F5 AFM port there. We have a DSSM, the Sentinel, as well as the F5 TMM. Within the F5 TMM, if I look into the details, there are a few containers that consists of there are a few containers that form the port. For example, I have the F5 TMM routing as well as F5 TMM TM route D. If I jump onto the F5 TMM routing, you can see that basically that's a ZBoss, enable show IP BGP. You can see that what happened here is that remember that I have a router called 10.1.20.41, which is this one, 10.1.20.41. So what happens is that this route is pre-configured to do a BGP peering with the F5 TMM. and advertise him as a default gateway. That's why you can see that when I spin up, you can see that the F5 TMM routings already detected and do the BGP peering and send it to the internet routers. If I show running config, you can see that this is all the configurations that is pre-configured in the value file. All right, now, so okay, so now I have set up the F5 TMM, but I haven't set up any CGNAT configuration yet. So in order to set up the CGNAT configuration, what you can run is you can run CGNAT onboard, another script that I'm going to show you what exactly these scripts are doing. Basically, it's deploying a HSL, is creating a security log profile, it's creating some routes, it's creating the NAT policy one, it creates a secure fastl4 v426, as well as it creating a NAT policy 2 that is for the for HTTP and HTTPS. There's another tools in here that you can run, is TMCTL debug, where it will show all the virtual servers that got created. Currently, if I run that command, you can see that there's a 4 virtual servers been set up. Here, there, that is the one that when I run it, there's no pool member because this is doing the CGNAT out to the internet. Now, if I go to the client, so now the thing's already set up. If you want to check the logs here, the AFM, you can see that they're really having all these gRPC clients connectivity happening. The NAT blocks already been pushed down. So now what I am going to do is that I'm going to jump onto this one. There's a couple of you can either log in directly from the UDF, which, let's say for example, if you in the next demo, I'm going to run the Argo CD GitOps on the SPK, but in this demo I'm not going to use this. So you can jump onto the, like for example, Prometheus from for example, you can jump in from let's say here, the Grafana, or you can RDP to this host and you should be able to log in and see the, like let's say for example, this SPK TMM stats. You can see that it's currently is tracking it. This one is because I destroyed it. So now on the UE desktop, there's a 2 script there. The first one is actually this. You just for IPv6 only interface, you should run this first. For example, this is just to set up the environment to make sure that my desktop is actually only IPv6. If I -6, what happened is that there's one IPv4 which is on the management, but we are not going to use that. The one interface that we are using is ENS6. Currently it's set up FD3016. So what I mean is that currently my desktops are, if I run -4a, as I mentioned, is only the management which is connected to the management. So now this box currently is already running IPv6 only. So if I do a dig, for a curl, for example, http web1.spk.local, give it a okay. Now you can see that I'm able to access the backend server 10.1.20.31 on port 80. You can see that the client IP address 10.10.10.5 and 50.22. So basically that is, you can see this keep changing because I'm doing a pad 50.26. If I try to connect to the internet, for example, I got a web server on the internet, aws.foobs.com.au. You basically get the public IP address. You won't be able to see the real IP address because, as I mentioned, this thing's actually, the router is actually doing the netting as well. Right, if I call HTTP as YouTube, let's say youtube.com. Okay. Yeah, you can see that I can get to the youtube.com, which is going to the internet. So this is the NAT64. Apart from that, you can actually check the Kibana if in the app stack. If you want to see the HSL logging, actually is sending to the app stack. You can into this. You go to the discover. Currently, the logs are all sent to the app stack. You can see that where it is hitting. These are all the logs. It's coming from my SPK fast46, and the destinations. All these informations are are sent to ELK. All right. Then the other things that you can run the TM debug tools as well to see the number of hits that I had in here. Like for example, this is 46. There are 9. For HTTPS, there are 8 server connections. Within the SPK, there's a debug tool, as I mentioned previously. It's called BDT tools. You can check the connection table if you want to, but again, this is more for the debugging. If you choose number 3, number 3 will give you it's not very user friendly in terms of the connection table, but all these things you can use it to debug the connections. Or you want to look at the routing table or the TMM routing table on number 4. This is all the routing tables that you can see that now the default gateway is actually pointing to 10.1.20.41. Alright, so now we have this IP NAT64 is working. The other things that I think is good to mention as well, that there's a there's a DNS64 is running currently on this big IP DNS64. So what happened here is that if I dig web1.spk.local, so because this thing is actually pointing to DNS64, the DNS64 will receive it and then will talk to the local DNS to synthesize the IP addresses for those that only have IPv4 into IPv6, because this environment can only talk to IPv6. That's why if I dig let's say for example just now when I youtube.com, for in this setup I synthesize it as well. So regardless of whether regardless of whether the sites have IPv6, everything will be synthesized to 64 FF9B. So that's why I'm able to connect using the FQDN. If you want to connect using the IP address, that will work as well. Alright, now what I'm going to do is that I'm going to demonstrate the NAT44. Previously, I already have the NAT44 setup. In fact, if you look at the onboard CGNAT onboard, you can see that I actually at the same time I deploy NAT64 configuration as well as the NAT44. Maybe I quickly run through CGN, give you a quick overview on how's the configuration look like. For example, for the NAT64, the NAT policy, I've set up to say that everything's that netted to 10.10.1/25. The way that I split up here is that the first half of 10.10.10 will be NAT64 and the other half will be NAT44. And the source IP address, this is my, basically I just say that my machine or anything coming from this source addresses will be doing a dynamic pad. And if I look at the other one, I have the HTTP and HTTPS, and what I want to show you, the NAT64, let's say one of the secure fast L4. Basically what it does is that once it matches this, if it's port 443 TCP, it will run the NAT policy and it will send to the HSL. What is in the HSL is actually create a HSL pool similar to what we have in our big IP, send it to the HSL pool with the format RFC 5424, and that's where you can see the logging here. Okay, now for the IP for the NAT44, so what I'm going to do is that I'm going to change my desktop to IPv4 only. That's where I written another script called IPv4 only. You just need to run this script. So what it does is that it's actually set up the environment to be IPv4 only. If I run IPv4, alright, so if I IPv4a, so now my desktop, now I already changed it to 10.1.30.16. So this is the IPv4. If I do a dig web1.spk.local, this 10.1.20.31 is the IP addresses of this one. So if I run the curl again, curl http web1.spk.local, you can see that it's actually doing the netting. Now you can see that the destination is still the same, but the client IP address is on a different half of the 10.10.10. Remember that this is the second half. Oops, sorry. The second half is 10.10.128/25 is the IP NAT44. You can see that as well as the client is keep changing as well as the port. if I go to the logs, give it a couple of seconds, you should be able to see that what happened is that when the HSL sent to there's a fluentd actually running in here. What happened here is that the fluentd will do a buffer instead of every times when the fluentd receive. So I'm using the fluentd as a buffer to write the data directly to the Elastic for the indexing. So that's why, yeah, now you can see that. You can see that this is now currently matching the rules is NAT44, and I am accessing the destination of 10.1.20.31 because the DNS NAT and my source IP address 10.1.30.16, and you have all the informations that is you required to look at the true what is the translated IP addresses, what's the destination IP address. Now if I run the BDT tools, sorry, not the BDT tools, TMCTL debug. So you should be able to see that the IPv NAT44 now currently matching the 8. I haven't run any HTTPS, so that's why it's 0 there. The other tools that potentially is useful is a config viewer. I want to see op, so there's no configuration here. Yep. That's it. In the next video, I'm going to demonstrate the GitOps with SPK. So to demonstrate the true cloud native capabilities of SPK CGN, as well as the traffic management to the Kubernetes applications that is currently running here. Thank you for watching.